side.
If I see a square root, I can undo it. He said, Professor, jump in and do this. You gotta do it on each side. That's no problem. Left-hand side's nice. A square root, I'm gonna end up with m subtract 1, that's no problem. The problem is the other side. What is m subtract 7 squared? Let me first tell you what it's not. It's not m squared plus 49. That's what I see so many times on quizzes and so forth. It's not m squared plus 49. Does anyone think they know what m subtract 7, that binomial they call it? Those two terms. Squared will give. Not m squared plus 49. Go for it.
A squared plus.
Well, hang on, I got an m. M squared?
M squared plus, I think it's gonna be, or no, negative, minus 14 m.
Got you?
And then, plus 40.
That's what it is. There's a professor, now how did he get that so fast? He probably, in his mind, was thinking, Professor, this means this. M subtract 7 times m subtract 7. Let's multiply those two together. And we're back into this. Sometimes students come and say they use something called FOIL to multiply it out. For some students, we use a distributive property to multiply it out. You do have a minus 14 m there, then plus 49. Guys, I'm looking at now, oh, by the way, since I've done that squaring on the right-hand side, does this look now more like a quadratic? This is now going to turn into a quadratic equation. So I'm not getting to the quadratics back there to make this lesson connect. First, though, I need one side to be 0. All my other sides eventually come out to be 0 over here. Got to move the m over. Move over there. And the 1 over. And my 0 here. Either side can be 0. As I move that m over to the right, I'm subtracting. I'm going to end up with a negative 15 m. So I've got m squared minus 15 m. If I move that 1 over by adding 1, 49 plus 1, 50. One reason I love mathematics. I used to get so aggravated doing the higher level mathematics in grad school. All of a sudden the professor would just do something so simple. I said, are you kidding? That's all you had to do? For energy, of course, that's all you had to do. For energy, didn't see it at the time. Who on earth would think that that original that had a square root is the original? What's this? They're equivalent. Now, since I've changed it to this, I can solve it. Now, which method would I like to use? Either factor, use quadratic formula, or complete the square. I'm going to try to factor it. That's the fastest you can do it. Some of these will not factor. Let's do that later. Guys, you guys who are strong on factoring, I'll get you started. It's going to be an m and an m. Anyone tell me what the factors of 50 and get a 15 in the middle there? See, hang on. I'll get her. She's way in the back there. Yes? Negative 10 and a negative 5. She's telling me, Professor, negative 10 times a negative 5, that's positive 50. If you add up negative 10 and negative 5, you get negative 15. It's got to be that. Now, since I want answers, thank goodness I can use what they call a zero product property. I'm allowed to set each one of these equal to 0 because of this 0. It allows me to do that. Okay, we end up with 10 correctly and a 5. So right now, back here, the original equation looks like it might have these two solutions. Now, I'm trying to think to do something with you guys. Okay. Should I, if I saw this on the quiz Wednesday, should I be okay, just move on and feel comfortable to turn my quiz in? I would not be comfortable here. More than likely, I would check it to make sure. One of these answers, both, wouldn't that be really terrible? Both do not work. I've done all that work for nothing. The guys that check here, I ain't gonna check these. Check. Who knows, the 10 may not work. I have not checked it. I'm gonna check it now. I go back to the original, put a 10 in, this becomes square root 10 subtract 1 Right-hand side, replace the m by, 10 on the other side, 10 subtract 7. I know that's square root of 9, that's a 3. 10 subtract 7, 3. It checks. The other, I'm checking now, maybe 5 will not check. Sometimes I've seen somebody for one may check, the other may not. Maybe both will not check. Going back to the original, put a 5 in, square root 5 subtract 1, back in the original, is that equal to 5 subtract 7? Checking the 5 there. Left-hand side, square root 4. Is that 2? And the other side's what? We caught one here. It's not gonna work. The two sides do not match up. So out that quadratic, I have to now, not use the 5 and go back to wait, Professor, this one's out. The only answer is 10. Not 10 and 5. I gotta go back and make sure I do a check there. Okay, guys? And one more here. I'll tell you what I want you to do for me. Looks like, yes. Now I'll get you guys started here. I want to try this. Solve part B. Use a different color here. 2 over, let's call it n. N subtract 2 rather than x. Equals 3 over n plus 5 plus 10 over n squared plus 3n subtract 10. Make sure I got all that copied down correctly. And the rest is solve for n. Now, since the last one we'll be doing, then we'll have you guys do something for me. Guys, is that a quadratic? If it's a quadratic, I'll use quadratic formula or a factor, or do what I gotta do, or is it linear? Or can you tell right now? Now, one of my students said, Professor, I think it's gonna be a quadratic. If it is, I'll go back to factoring, quadratic formula. I don't want to bring the square, even though I could. Yes, go ahead.
I have a question.
Go ahead.
Couldn't the square root of 4 also be negative 2?
Here we go now.
The square root of 4 could also be negative 2.
Okay, where are we back? Oh, you're back.
Yeah.
Oh, beautiful, here, beautiful. Don't you dare leave this classroom. And another professor or student says, square root 4, I love this. If that's all you see, just square root 4, answer is that. If you see this, outside class, now what's the answer? It's plus and minus.
Oh, okay.
That's the big difference. I'm glad you brought my attention to that. That's the big difference. So if you see that square root symbol, they're looking for the positive square root. If you see x squared, they're looking for 2 answers. There's plus or minus 2. So glad you asked about that. Guys, on this one for me to finish up what I want to do here before we take a break here shortly. I heard a student say, Professor, I think it's quadratic. It certainly doesn't look quadratic. What might you do? Wednesday, give you that strange look, taking the test. What's wrong? Take the quiz. I don't know what that does. I don't know what to do. I'll see you in the fall semester, Professor. Any ideas, guys?
Is it called a reciprocal function?
No, not reciprocal. There's something that has to be done that you've done many times, but you may not recognize tonight. You've done this before. I've got to clean that up. It might be a quadratic. Certainly does not look like a quadratic right now. Or it might be linear. That's why I'm ending with this one. Get a hand back here. Yes?
You factor out the quadratic, and then you find n plus 5 and n minus 2.
Oh, hang on to that thought. Love it. She said, Professor, this will break down into by factoring. She says n plus 5 and n subtract what? 2. That's true? Well, how nice. I made a mistake, those in the green, do they sort of match up with the two that were given? So there's something going on here. Now, someone tell me, where should I go from there? That's all, also I hand in the back to do something. Yes? Not conjugate, not conjugate. Something else. Yes?
First, we should rule out the n equals 2 and n equals minus 5.
Hang on. Love that. You said, wait, Professor. Just in case, when you finish up, you cannot let n be a -5 or a +2. What would happen if I replaced n by a -5, or a +2? These would become what? 0. Is that true? And I can never have a 0 denominator. So after I finish up, I don't have the answers yet here at the end. But I'm so glad the attention was called here. Professor, you cannot use 5. If you get it, reject it. And you cannot use -5. And you cannot use a 2. Now what is it? Maybe the answer is 3. I don't know what the answers are yet. Now someone help me out to close this down. What am I going to do with all this beautiful response so far though? What are you going to do? Because you get a little partial credit for this already. Yes?
You cross multiply?
Not yet. Something else, we want to keep it mathematically sound. Yes?
You subtract 3 over n plus 5.
You want to move this over here?
Yeah.
You could.
Okay.
You can move things around as
You
much
also
as you wish. Okay, I could.
Move 2 over n minus 2. That the whole thing equals 0.
Or you want to move everything over and get one side to be 0. No problem. Absolutely no problem at all. Definitely that is an approach. Something else. No, you said it correctly. But something else. It may take me there. Yes.
Aren't you have to make the denominators all the same?
Yes.
There's something with those denominators. I have a denominator here, n subtract 2, denominator n plus 5, and all of a sudden, the student who said factor this, Professor, they came out again. So I think what the students tell me, saying, Professor, put all this over the same denominator. And what is that common denominator? What do I want, do you think, for the denominator of this, and this all to be to match up? I want the green. I want the green. I want everything to match up. If I want the green, n subtract 2 with what she gave me earlier, it's missing, this is an n here, not x. It's missing n minus 2 is missing what? N plus 5? I need to put n plus 5 in here by doing this. Numerator, denominator. Now, it's also underneath the first term. Well, the second term is missing. If I want a common denominator of that green, it's missing the n subtract 2. I've got to put it in. Now, please tell me, are all the terms over the same denominator? At this point, after I did that adjustment, okay? Now, what do we have all together, guys? I need to clean this up, do not make a mistake. First term is 2n plus 10. That's distributive property. Over that common denominator, I'll just leave it like it is. I'm not going to multiply it out for a reason. On the other side, I got on top there my numerator, 3n subtract 6. All over, yes, here we go again. I'll write like this in that order. That same denominator. Then of course we got a plus 10 out here over same denominator. Whew. Guess what I get to do now? I could, but I think I see something that might lead me to the answer faster. Since they're all over the same denominator, what can you tell me is going to happen? Let's not say this right here probably is equal to this side over here. In other words, will these just sort of drop out?
Yeah. Just put one denominator.
Yes, just one denominator. You could, by the way, you said, I love that too. You're saying, Professor, you could even do this. All kinds of responses here. He says I could put these two together just as one term. if I wish. And that one term is still over this. Good suggestion there. Now guys, if I put it together, he's saying, Professor, put those two together. Combine it into one. If I do, I got 3n subtract 6 plus 10. What is that, 3n plus 4? Good suggestion. Now keep in mind, I still got this over here. Over this. Looks like that. Yeah. Thank you. Okay. Now, guess what I get to do? That's not, you made it look better. What can I do now? You gotta get an answer. Will these two eventually drop out? From side to side, they match up. Will they drop out? And you say, Professor, how can you make them drop out? Some textbooks will say, yeah, I have students do this. Multiply each side by that common denominator of this. Multiply each side. If I do, this and this will drop out. On the other side, same. Product here. These will drop out. And you may see that we're not going through all that. It's going to come down to, guys, up here at the top. We're going to end up with 2n subtract 10 is equal to what? 3n plus what? 4. Now me, as much math I know, here's the original blue. This is the original. Professor, are you kidding? That original blue was what you say in math? Why didn't you show me that first? That original blue over there came out to be just a simple equation right here that every student in class can solve this. So who would have known that this is going to do that until you clean this up? So the original blue here turns out to be that black equation. Guys, to solve it right quickly, I'm going to start moving things around. Move that over. Move that over by subtracting. Please tell me if we're going to end up with, be careful here. Yeah, n is equal to 6. Jump back and look at it. I did it quickly. Is it 6? We solve that simple linear equation. Now I have my plans tonight. I started out with, I'll play this precisely. I have a break here. I thought I'd better start out with way back there somewhere on the board. I don't think I raised anything. I started out with this. That's the first thing I mentioned tonight. We went through the syllabus. And guess what I ended with before the break? A linear equation. Did it look like it's going to turn out to be a linear? I didn't know. I didn't know myself until I jumped into it and cleaned it up. This is a linear. It could turn out to be a quadratic. But it turned out to be a linear. Looks like the answer is 6. Now here's the sad thing before we take a break. It would be so sad if on the quiz I gave you one of those. And all of a sudden you say, Professor, I feel so good about that problem. I just know I got it. I let it just suggested. And I got 6. And it doesn't check. You go back, you replace in the original blue 6 for the n, and all of a sudden, all that effort that you went through, it does not check, and all of a sudden you have to say, no solution. I'm talking about salmon, that would be sad. Use half sheet paper to get to 6. Close this down, we'll take a break. I'm getting a little nervous myself. And I went through a lot of work on this to get 6. If 6 doesn't work, we did it for nothing. Okay, we'll go back to the blue guys, and we'll replace n by 6. It looks like this. Replacing n by 6. Plus 5. And 10 over, look at this. Original, 6 squared. Plus 3 times 6. Subtract 10. Now, set backward. I placed all the n's, guys, in the original blue by 6. Now, it's not gonna be a happy break if this does not check. Your professor's not gonna be happy, you're not gonna be happy. You're gonna spend the next 15 minutes on your break sad. Because we went through all this work for nothing. We could take a break early. Okay, so just go check. Guys, this is 2/4. Can I call it 1/2? I got 3/, oh my lord, 11. I'm getting scared. 10/, 6 squared, 36. Plus what? 18, 36 plus 18, help me out, 36 plus 18, is that 54? What is 36 plus 18, is that 54? And then subtract 10, gives you what? 44. Okay. 1/2 is equal to, now, on the right-hand side, I need to put those two fractions together from elementary school with the common denominator of 44. Now, let's do that, let's multiply this by 4, top and bottom, numerator and denominator. Now, they're both are the same 44. On top, I got 12 plus 10, is that 22?
Yeah.
Over 44, which I think reduces down to 1/2. Then Wednesday, I look back, I see a smile on your face. It checked it. If I look back Wednesday, I see you crying. Professor, you're gonna be a problem that took half sheet of paper. It doesn't check. This one checks. Not know for sure the final answer.